Welcome back, Physical Science 20. This is the beginning of the HT unit on heat, and this section deals with HT1.1, warmth and coldness. So here we'll be looking at describing the kinetic molecular theory of matter, explain what is meant by thermal energy, describe what temperature is, and describe how a thermometer operates, describe the relationship between Celsius and Kelvin scale and be able to convert from one scale to another, define melting point, freezing point, describe the relationship between the two, also define boiling point, condensation point, describe the relationship between those two. So the first two sections here, HT 1.1 and 1.2, are more qualitative, meaning that there aren't a lot of things that we're going to calculate. Just going to basically look at concepts involving heat. So the first one, warmth and coldness. We can think of them as being produced by vibrations of atoms and molecules. So during the 18th century, scientists thought that warmth and coldness were produced by a massless fluid called caloric, this mysterious caloric. Scientists believed that the amount of this fluid in the universe was constant and that it flowed naturally from warmer objects to colder objects. In 1798, English scientist Benjamin Thomson, known as Count Rumford, published his investigations showing that caloric, unfortunately though, this mysterious fluid, did not exist. Count Rumford noticed that when holes were drilled into large, solid iron cylinders used to build cannons, the drilling apparatus and the iron cylinders would become very hot, even though both had been lukewarm at the beginning of the process. So that shows you that it's not necessarily from a hotter to a colder object because neither of them were hot to begin with. This seemed to imply that caloric was not the flowing from warmer objects to colder ones, this mysterious fluid, but was created by the rubbing of two objects together, just like rubbing your hands together when it's cold outside. We, of course, know it generates a lot of heat. Up until this time, scientists thought the materials could become hot only if they are in contact with, of course, hotter objects. So you had to have a hotter object for that object that wasn't hot to become hot. And that could transfer the caloric between them. Count Rumford's investigation caused scientists to lose confidence in the caloric theory's explanation of why objects are hot or cold. Instead, scientists began to explain warmth and coldness using what is referred to as the kinetic molecular theory. And of course, the word kinetic means moving, kinesthetics, body movements, etc. So you can think of it as the moving molecule theory. It's based on the idea that matter is composed of particles, i.e. atoms and molecules, that attract each other and have kinetic energy. And of course, kinetic again means moving. So energy due to movement. It is the kinetic energy that causes particles to be in a state of constant motion. So the moving energy implies that atoms and molecules are constantly moving. In a solid such as ice, particles are held in fixed positions, but they vibrate. So you can think of solids, they move too, believe it or not, but simply vibrate. If you hit a table, you can feel the vibration of the table. So we can think of it as, unrelated to this picture here, so you can see a solid and atoms or molecules are close together. So there isn't a lot of movement allowed. They just simply vibrate. If a solid is warmed up, the particles remain somewhat fixed but vibrate more rapidly. According to kinetic molecular theory, an increase in the motion of the molecules makes the substance feel warmer. A decrease in motion makes it feel colder. So if you look at a liquid, such as water, particles have more kinetic energy than those of the solid, and they vibrate more rapidly, moving from place to place. And you can think of liquids are further apart, so what we say is that their movement is more flowing. So we could say here, liquid, atoms, further apart. So solids vibrate, liquids, the molecules and atoms are moved further apart so they can actually flow past each other. And then lastly here, the particles of a gas have even more kinetic energy than liquids or solids. They can vibrate more rapidly, and you can think of the word there is float around. So they can float. So gases, atoms, even further apart. So we could say here, float. So solids vibrate, liquids flow, gases float, because of how close the molecules are to each other. So that brings us to thermal energy. Particles of matter possess many forms of kinetic and potential energy, which we'll talk about in a bit. Much kinetic energy is associated with motion. So yes, again, kinetic means moving, so moving energy. Other atoms or molecules have potential energy, which is not due to movement. So potential energy deals not with moving energy, but looks at the force of attraction between particles via stored energy. So you'll often maybe been told you have so much potential, that's storage of something. Think of an elastic band being pulled apart. You know that if you release that band, it's going to change into kinetic energy or moving energy, right? But stored energy is that energy that exists due to the condition or position of something. The amount of kinetic and potential is called thermal. So you can write down this little graphic right here. Thermal energy is equal to kinetic energy plus potential energy. Combination of both. In general, the amount of thermal energy within an object determines how fast it'll move, therefore how hot or cold it gets. When an object or substance absorbs thermal energy, it warms up. When it releases thermal energy, it cools down. So absorb, warms up. Releases energy, cools down. So when you feel cold, for example, it's not because you're gaining coldness, it's because you're losing heat, you're losing thermal energy. Thermal energy can be transferred from a warmer object to a colder one, but not from colder to warmer. Thermal energy of an object can also be transformed into other forms of energy. Thermal energy, like other types of energy, are measured in the unit of joules. So please highlight that. Temperature and thermometers. If thermal energy is responsible for warmth and coldness of an object, how do you measure thermal energy? Unfortunately, there isn't an easy way to measure thermal energy because it's impossible to measure the kinetic energy, potential energy of every particle. So you can't do that. You can't measure every single particle. However, there is a way to measure the average kinetic energy, so the average moving energy, and that in fact is what temperature is. Temperature measures the kinetic energy portion of thermal energy, the moving energy portion. So let's highlight that, maybe underline that. Kinetic, and of course average, because different molecules are doing different things, but on average, how fast are they moving? Notice that temperature is a measure of average kinetic energy, not kinetic energy, not total. The reason is that particles in an object have different amounts of kinetic energy. Some are moving slightly faster than others. However, the majority of the particles of a warmer object move faster than the majority of the colder objects. So the temperature of a warmer object is higher. So you're measuring kind of on average what's happening. It's like saying the average test mark in a certain unit. Everyone has a different mark, but on average, is it a higher average than class A or lower than B, or is it lower than B? Temperature is often measured using a mercury or alcohol thermometer. Of course, we use alcohol ones now. These thermometers have narrow sealed glass tubes containing the alcohol. When a thermometer is placed in a substance that is warmer, the particles of the substance bump into the glass of the thermometer. As the temperature of the substance increases, these collisions can cause the particles of the glass to vibrate greater. In turn, the fast-moving particles of the glass collide with the slower moving alcohol inside, making them move faster as well. These faster-moving particles of alcohol begin to spread out and take up more space. So if you look at this page, you can see that. So the faster-moving particles, because the more energy it has, the higher the temperature something is, the faster it's moving. So these outer molecules move fast, hit the glass of the thermometer, causing those molecules to move fast, which hit the alcohol in the middle, causing it to move fast. And of course, it's moving faster and it has room to spread out by moving up. So this causes the liquid in the thermometer to move higher up the tube and give a higher temperature reading, just like over there. Okay, I think we'll stop that video for over 10 minutes, and then part 2 we'll look at, well, how does it work if the thermometer is placed in the colder area, and we'll look at the rest of this section.